Hello everyone, today we are going to solve GFG problem of the day, 2D difference array. So let's see what the problem says, then we will move ahead to its solution. So in the problem, we have been given a matrix 2D array and one operation that is also a 2D array. So in this operation, the first value is this val and the rest of the things are the coordinates corresponding to this matrix. And what we have to do is all the values following in those range we have to add plus 2 in that. So let me do the indexing, and so after indexing what it is saying, from 0 0 to 1 1, whatever value following in this range, update everyone by 2. So what are the values following in this range? This, what you see in this yellow is whatever is occurring in this range. So let me create an array where we will be storing after updation. So it is saying in this 1 to 2, update everyone by 2. So 1 plus 2, 3, 2 plus 2, 4. This 3 is not lying in this range, so it will be untouched. 1 plus 1 is, sorry, 1 plus 2 is 3. 1 plus 2 is 3. 0 not lying in this range. And these also not lying in this range. So it would be remain as it is. Okay. So now its work is done, but there is another one that also we have to do. It is saying apply -1 in the range 1 0 to 2 2. So let's say 1 0 starts here, 2 2 is here. So whatever is lying in this range, update them by like add -1 to them. So here, if you see in this range, we have 3 like this. So 3 minus 1 is 2, 3 minus 1 is 2, 0 minus 1 is -1, 4 minus 1 is 3, minus 2 minus 1 is -3, and 2 minus 1 is 1. Now this one is done, this one is done. This is after applying all the operations. And if you see, this is what we have to do. So after applying all the operations, whatever is our matrix remains, just return that. That is what is being asked from us in the question. So let's see what can be its solution. First solution, brute force. For every queries, go from starting to end, from here to here, and update everyone. Next, if next query comes, go from this to this, and so on. So this is the brute force approach. The time complexity will be, let's suppose there are 1 2 till q queries. So the time complexity will be q into n into m. That would be our time complexity. And in space we are not using, so O of 1 space. But can we optimize it? So let's try to optimize it. Sorry. So if you see from 0 0 to 1 1, what in brute force what we were doing is, in this range we were updating in this range, right? So let's try to optimize it. So I don't want to go every time and update every time. So what I am doing is, let's say I am taking a matrix. If it is 3 cross 3 matrix, let me increase 1 to row, 1 to column. So 3 plus 1 into 3 plus 1. Like I am taking the here 4 cross 4 matrix. Okay. So in this 4 cross 4 matrix, what I want to do is, I want to have an effect of plus 2 in this range. In the range 0 0 to 1 1. So let me do the indexing as well. So in the range 0 to 1, like in this red range, I want to have an effect of plus 2. So let's see how I can do that. So let's say I do here plus 2. Now here I did plus 2, and let me add minus 2 here just after the range. Here also this was our range is, so just after our range is finished, let me add minus 2, and here also like diagonally also just after our range finishes, let me add plus 2. So let's see what effect it is having. So this part is like, hope you got idea, but how are these effects are going to come up in my final matrix? So what I will do is I will start, let's say, let's apply first all of the effects. So this Q effect is done. Now this effect, apply minus 1 in the range 10 to 22. So my starting point is, this is my 10, this is my 22. So let me mark it with something like this. In this range, I want to have effect of minus 1. So let's see how I can do that. So let's first consider only for plus 2. So in this range, I want to have an effect of plus 2 only. So what I will do is this, I already told, just go one outside the range, and for for row, just do minus whatever the value, for column also, but for diagonally add plus 2. So let's see if this was my only operation, what effect my overall matrix would have got. So what I will do is after that I will keep checking from this value whatever was added there. So if I check here 2 was added, so I would say I would also add 2. If there is minus 2, I would go back and check what was earlier added. So minus 2 plus 2, here 0. Here I will go back and check what earlier was added. Earlier was 0, so I would also add 0. Now here, so this point I am not starting, right? Every time I am going back and checking. So for going back and checking, I am starting from just after, from this point I am starting. So this I go back and check. So what effect I had? 0, 0, like 0. Here I went back and checked. There was minus 2, minus 2, plus 2, minus 2. Their effect is 0, 0. And there, from if I start from here, 0, because nothing is there, right? Now I have done traversal row wise. Let me try to traverse now again column wise. So from row we were start looking back. That's why we were starting from here every time. Now column, when we want to look back, every time we will start from here. So I will see what earlier, what here plus 2 effect. So I would say plus 2. Here also I wanted to apply plus 2. So I would go back here. Like from here, I would go back here and check what effect was there. Like this I will be doing. So let's do like this. So first there was 0, so I checked, there plus 2 effect was there, so plus 2 I applied. Here if you see, I go back and checked what effect was there, plus 2. So minus 2 plus 2 is nothing but 0. Now here I would go back and check 0. Okay, till this point I hope it is clear. Now here I went back and checked plus 2 effect, and that is plus 2, right? Here minus 2 is there. I went back and checked what effect we have. Minus 2 plus 0, that is nothing but 0. Now this point I went back and checked 0. Here 0, so it will check 0, it will check 0. So no changes. This row no changes, this row no changes. So if you see, the only changes we applied in this range is this only. So this would be going to be our approach. So we will apply plus 2 at the starting position in row wise just after our range ends, in column wise just after our uh, or like origins and like where our coordinates end, in row wise where our coordinates end, and in diagonal wise also where our end just after plus 1 we will apply 1 plus 2 effect, right? That's what we did. So this is the effect which we got if there was only 2. Let's try once with all, like if there is minus 2 as well in the coordinates. So let's see what effect it would have. Earlier, let's say there was everything 0 0 in my matrix, and plus 2 effect I want to generate. So I did plus 2 in this range, right? In this range only we are considering. So in this range plus 2 I want apply effect. So here minus 2, after the just after the range apply minus 2. This is my range, right? Just after the range apply minus 2, and there will be no change. And just after the diagonally change apply the plus 2 effect. This is done. This is done. Now let's consider its effect. So now let's start applying the effect of this one. So we want to apply minus 1 effect in 1 0 to 2 2 range. So let me mark it. This is our range. In this range, we want to apply the effect of minus 1. So here 0 is there. Let's do minus 1. Just after my range, add, like 2 was there. So we were doing minus 2 after the range. So minus 1 is there. So I will say, let's add plus 1 in our range. Here also my range ends just plus 1. And here also my range ends diagonal wise. So I will add just minus 1. Now let's see what the combined effect of these plus 2 and minus 1, and how will we go reaching our solution. So first what we decided, first we will apply the effect, then the second thing, traverse row wise first, then column wise second, and then that will have all of our effects. So let's see, first apply effects row wise. Plus 2 is there, go back, check, we had applied effect plus 2, go back, check, there is one effect applied already, so it minus 2 plus 2 0, go back, check 0. This 0 would go back and check, there is minus 1, so it would say let's apply minus 1 here. This would go back and check, at minus 1 was there, and this would go back and check and say 0 effect. Till this point, I hope it's okay. Now this 0 would go back and check what effect earlier we had. So 0 minus 2 minus 2 plus 2 minus 2 0, and it would go back and check 0. No, it would, now it would go back and check plus 1, it would go back and check plus 1, and it would go back and check effect 0. Okay, now row wise we are done. Let's do column wise. Minus 1 plus 2, that is plus 1. So plus 1. Minus 1 plus 2, sorry, Like this we will go first. Minus 2 plus 1, minus 1. Plus 1 minus 1, 0. Now this one. So every time what we were doing is we were starting from, not starting from 0 0. We were starting from just after it. So minus 1 plus 2 plus 1, minus 2 plus 1 minus 1. Okay. 0 minus 1 minus 1. Okay. I'm sorry. Like this. Plus 1 minus 1, 0. Now come here. Minus 1 plus 0 minus 1. 0 minus 1 minus 1. Plus 1 minus 1, 0. And this. So if you see at the end, what we have is this array. And in this array, whatever is stored, that is overall effect that will be in our matrix. So let me construct a matrix and let me apply this effect. This is matrix. Here 1 plus 2 is 3. 2 plus 2 is 3. 3 plus 0 is 0. Oh, sorry, 2 plus 2 would be 4. Here 1 plus 1 is 2. 1 plus 1 is 2. 0 minus 1 is minus 1. 4 minus 1 is 3. Minus 2 minus 1 is minus 3. And 2 minus 1 is 1. So if you match 3 4 0 2 2 minus 1 3 minus 1 3, that is this matrix. So after applying our effect, this is our matrix. So what we did is we applied our effect in the matrix. And why it is working? Because first we were traversing row wise, then we are traversing column wise. So it is only applying this effect till here and this effect till here only. From this. So in this way, this plus 2 effect is getting applied only in this range only. So I hope you got the idea. Let's go to the coding. Let's see the solution. I have already coded it. So let me paste it. I will explain each line. So let's move to the editor and let me paste the code. So the first thing what we decided is we are creating one difference array. So this is our difference array, like this array we created, this one, this. So this array we will create. Here we will have all the effect. So this line is doing nothing but just applying the effect, right? So we are just at the ending row, we are applying effect, ending column, we are applying effect, and ending diagonally, we are doing that same thing plus one, plus same thing plus. So now the again after that we were applying this effect row wise, then the same effect we were applying column wise. So I hope till this point it is clear. After applying the effect, what we can do is this is our array list, and what we are doing is in that after applying those effects, whatever was remained, like if you remember, this was the our difference matrix. So if we were adding this part to this, we were getting our solution. So that it is doing nothing, just keep adding whatever is in that my whatever is there in my that matrix, this is doing the same. So let me this is plus equals to whatever was in my different matrix. So difference I comma j, nothing, just this much, just add that to our matrix and just adding it my row whatever I have created, because we have to return array list of integer. So that's it. I hope it should work. It is getting compiled successfully. Let me submit it. So it is getting submitted also. So if you see what is the time complexity, first this is running q times, right? This is n into m plus n into m, again n into m. So if we say the overall time and space complexity, so space complexity, we have created one array. So space complexity, we can say n plus 1 into m plus 1. 1 is constant. So we can say big of n into m is the space complexity. And time complexity is, if you see, this is running q times and n into m into 3. Like this is n into m times, this is n into m times, this is n into m times. So space complexity will be big of q plus 3 into n into m. 3 is constant, big of q plus n into m would be my time complexity. So I hope you got some idea of the problem. If that is, you can like the video,